let's begin our first lecture on elementary number theory. Here I want to talk about divisibility. And warning, mathematicians, please try to avoid this video and also the series. Otherwise, you may suffer IQ insults. Here, absolutely, there are some basic definitions and properties of divisibility. So let's take a look at them. For the first one, what is divisibility? Suppose that A and B are positive integers, or maybe in natural numbers, while B is not zero. If there exists an integer C that makes A equals B times C, then we say that A is divisible by B. Okay, so we write it like this. We need to pay attention that here we mean that, yeah, the division. But here we need to know that we write B in the front while the A follows after this. So if if A cannot be divided by B, then we write it like this. Right? Like this. Just to add something like this, like on it. Okay, that's the basic definition. Let me erase it so we can leave more space for other properties. Erase, 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 erase. Alright. Let's use blue for our properties. For the first one, if C is divisible by B and A is divisible by C, that derives A is divisible by B, like this. For the second one, if A is divided by B and A is divisible by B and C is divisible by B, we can derive as that A plus C or A minus C is divisible by B. That's easy to understand, isn't it? Well, the main thing B, let's suppose that A equals A1 times B and C equals C1 times B. Here the A1 and C1 are all positive integers because A and B, C and B are all positive integers. Good. So A plus C equals B times A1 plus C1. A minus C equals B times A1 minus C1. Yeah? It doesn't matter whether after minus is positive or negative. Yeah? So if it is negative, you just change A1 and C1's position and it will be positive. Let me erase this. Yeah? To erase this explanation. Put another one. Okay, blue goes on. For the third one, if A is divisible by b, or always say a is 0, right? Then what can it derive? Hmm? If, uh, if if b is also divisible by a, that means a equals b. It's easy to comprehend, isn't it? Yeah, I mean that the a1 we had in the in the second property is 1, while the other is also 1. Yeah, easy. And it goes on. For the fourth one, also the last property, is that suppose, yeah, also suppose a and b are integers. This is the symbol of integers. Uh, for any a and b, apparently a may not be uh, divisible by b, and b may not be divisible by a. Apparent. Then, yeah, if b is greater than 0, so there must exist there exist q and r, which are also integers, that makes a equals b times q plus r. Here we have a demand for r, that's r must equal 0 or greater than 0. Okay? R must is 0 or it is greater than 0. Yeah, that's good. But it must be smaller than b. Must be less than b. Okay? These are all very easy to comprehend, and they will be the thing we'll use to look at some problems in the next few slides. It seems that we are left blank here because we have something like theorem you can understand like that, and maybe I'll use green to explain this. The first one, if n is a positive integer, then x to the uh, nth power minus what for the same, it can be explained like that. Ah, written like this. Yeah? Is it easy to understand? Though it's actually not easy to understand. Explaining this needs some knowledge of algebra, so I'm not going to explain this at this moment. For the same, I change it. I wrote it wrong. Yeah, for the second. N is a positive integer. The only difference is that we change the minus into adding. Plus. Here it is x plus y. You know what? it changes to minus as well. However, the next will be adding. You know, something like this. It follows on. And yeah, and the last two you'll find minus x and minus 2, and then plus 2. You must pay attention that the second one is only available one when n is an odd number. When it is an even number, it is unavailable. Okay, understand? Then to the next slide. And now, solving some problems. So, okay. First, prove that this number is divisible by 1001. That's a great number, isn't it? However, it is clearly shown that this way. So, we can use the equation we introduced in the in the in the last slide. So, yeah, where's my pen? Good. This number equals good. Nah, this is actually not necessary. Why we make 1000 here? Because we want to work out 1001. 1001. Okay? Then it equals 1000 plus 1. Able to understand, isn't it? Therefore, 201 to 10 is divisible to 10 plus 1 is divisible by 1000 plus 1 because we have it here and the original number is this. So you can write down the conclusion. This is just an easy problem. Let's go on to a little harder, maybe very hard. Very hard, I think. Suppose that, of course, we think that m and n are all integers. Here we suppose all the letters symbolize integers in elementary number theory now. M is greater than n is greater or equals to 0. Prove that complex. So you should understand this. Yeah? Understand? Instead, this is right. If you think that it is anti-4 like this is wrong. This is a wrong understanding. So you must change your thoughts if you thought that this number represents this. Huh? It is also similar like super exponentations. Maybe I will introduce it sometime. So you just remember the first equation we introduced? Hmm? Uh, for the x in that equation, x is now this number. However, when you do first with 1, this is x. What is y? Y is 1. And let's begin. And n will be n minus 1 to 2. Good? I will not speak at this moment. You may think by yourself. It might not be very clear here. Good? Is it acceptable? So, we look at the two numbers here. We have the first conclusion. Which one? Hey, good. What should we do next? What should we do next? Look at here. Here we plus 1. Here we plus 1. Let's use red to continue on. Basic algebra, isn't it? You should learn it in middle school, I think. Yeah? Yeah. Learned or will learn. Then we have the final conclusion. Right? Not final, actually. This number is divisible by this. And this number, yeah. Oh, I forgot to plus 1 here. This number is divisible by here. So we just have proved the initial conclusion. This proof is very great. And maybe it's a little bit hard to think about. Calculating the power of each 2 is actually a little bit hard. It's my own comment. Here we have the third example. Suppose that k is greater or equals to 1 and k is a non-number. Prove that the number k to 1 plus k to 2 plus k to n cannot be divided by n plus 2 for any positive integer n. Here you should be good at algebra. You know, we need to do something on this. Do something on this. do something. First, take n equals 1. It just stands, isn't it? It just stands. However, it's clear that 1 cannot be divided by 3. Yeah? We erase it now to save some space for the proof. Now let's begin. When is greater or equals 2? We take s equals reasonable. This is also reasonable. You may not understand what happens in the middle. Exactly after this, we have let me think. Yes. Something like this, and to the following. This. So erase it. For save space for the proof. Proof. Follow on. Because k is a positive odd number, so as the second equation we just talked about, it equals what? It equals what? Let's say it times a. A is a positive integer, you think? Any certain positive integer. And for all of these, in the middle, it also can be divided by n plus 2 for the same reason, isn't it? The pivots here, let's take out pivots. The sum is always n plus 2. Like we just say 3 plus n minus 1, it also n plus 2. So, every one of them, every one of here is divided by n plus 2. So, the whole number of what I circled by blue is divided by, can be divided by n plus 2. However, the two occurs in front of that guy. So, apparently then, 2a cannot be divided by 2. Right? Reasonable? Yeah, we shouldn't use a, it's s. Therefore, s cannot be maybe here it's more proper to say s is not good. Here's another example. Prove that there exist n different positive integers that the sum of any two of them is divisible by the production of the n numbers for all n greater or equals to 2. Good. Let's take these n different positive integers a1, a2 to an. Good. So, and we choose a positive integer k, which is uncertain here. Yeah, k. we expect that the production of Ka1, Ka2, Kan, the production of those things, Kn, yeah, this will be, this is divisible by um, the sum of any two of these. So just make it true in the from the question, isn't it? Here we can make an idea. Choose K. Because what? Because the production. Huh? Reasonable? I think it's reasonable. Choosing this. This meets the question's demand. Good. So just make uh, the numbers that the question wants. It's wonderful, isn't it? So maybe here will be the end of our video into divisibility. There may be some mistakes while I record my video. I hope if you understand or if you figure out there are some mistakes, you point them out and write in your comments. Thank you very much.